Hi everybody, and welcome back to Canal Sidings Model Railway channel. As you can see, it's a bit different this video. I'm sitting in front of the camera, not behind it, and basically it's likely to be quite short because my modelling time has been severely limited since the last video that I did about a fortnight ago, due to the fact that the day after that video was posted, my wife fell over and she's fractured two bones, one in her arm up here and one in her shoulder here. So she's trussed up in a sling, only got one hand, and I'm having to be mum most of the time, which I have to say I don't enjoy. Cooking is not for me. The easiest part of everything I find is the clearing up afterwards. Doing the cooking is not for me. Anyway, today I'm sitting in the conservatory. I've got the windows open. It's about 31 degrees in here now. It was cooler when I started to think about doing this video. But I have a small amount of progress that I've made, which I'm going to show you very soon. What I've been thinking about is how I'm going to produce the inspection pits in the two buildings on North Grove, and how I'm going to light them, and that's going to be the subject of this video. So without further ado, we'll turn over to looking at some modelling, and I'll show you what my thoughts are and how far I've gone. Okay, well, here I am in the conservatory still. As I said, the temperature is 30 degrees and I've got the windows open, so you will hear extraneous noises. But let's talk about inspection pits. You remember this building here, which is the Scale Scenes kit that I modified so that I could build it out of plastic hard and use some Wills siding on the roof and on the walls. That was the subject of several other videos. I now need an inspection pit inside it. Now, Scale Scenes do provide, with the shed kit, an inspection pit, and it looks quite good. But what I want to do is light my inspection pit, and I want to light it in a reasonably prototypical way. And although the Scale Scenes kit does have a lighting set available for it from a company called Black Cat Technologies, each kit does one length, which is this piece. So it goes, this is a double length building, so it does one length of inspection pit. So I've got two buildings, 3 inspection pits, so that's 6 times as much as one. The Black Cat Technologies lighting, good as it is rather expensive at over £12. So I would need 6 of them, £72. I'm afraid I'd rather spend that on putting it to a new loco or to a sound decoder or something for an existing loco. Excuse me. Dry atmosphere. So what I've decided to do is go my own way on this. And the easiest way to get an inspection pit is to use the Pico one. Here is a section of a Pico inspection kit. As you can see, it takes the rails through here. It's got the oh dear, I've lost for words. Not like me. So I'm looking for a pointer as well. It's got the drainage holes in the bottom here, and you get about, yes, you get actually 6 of these in a kit from Pico. So I thought that wasn't bad. I think the whole lot cost me about 20 quid or something, maybe 30. But you get a good solid inspection pit, and I would have had to spend a lot of time making one up using Inkscape and doing it to the Scale Scenes drawing. So I decided that wasn't the way to go. So I experimented with lighting on these sorry, I'm moving about a bit here. And what I did was I drilled a hole in the side there, and then produced this mask, which is just a bit of 10 thou plastic card, which I could put, sorry, the other way around, in there, like that, over the hole. If I can get that to show in the picture, there is the mask showing through the hole, showing in front of the hole, there's the hole. And then I could light the back of that with an LED. I can't show you in here because it's far too bright. But the LEDs that I chose were these. Now this is going to be difficult to demonstrate. I hope that's in focus. Yeah, it looks as if it is. These are 1.8 millimeter high brightness cool white LEDs, and if you can see, there's a little dome on the top of them here, which is what helps the high brightness. It tends to concentrate the beam. Now that doesn't help me because I don't want a beam, I want to spread the light as much as possible through there. So what I chose to do was this. Here is another one of those LEDs. Just drop my pointer. It's gone into the shag pile and I can't find it. Okay, I found it. Right, okay. This is one that I've taken the top off of. I don't know if you can see that, but I've actually removed the dome completely, and what I've got now is a flat top, which is not shiny anymore. It's frosted, and that does help to throw the light around a little bit. That's the way I did that, was simply to use my trusty sharpening block, diamond encrusted, and just rub the LED on until it went flat. The hole that I drilled actually takes, this is going to be difficult to show you as well, actually takes the whole of the body of the LED. In fact, it will go right through just. But what I intend to do is mount it. It's been through so many times now that I can't stop it from falling through. Let's try again. I intend to mount it so that it just about disappears into the plastic but doesn't stick out the other side. And I'm going to mount it horizontally, because this is a square-ended, a rectangular-ended LED. I'm going to mount it horizontally so that as much light as possible shines through my mask. As I say, very difficult for me to show you how that works because it's quite bright in here today, but it worked reasonably well. I was quite happy with it, and I can vary the current in the LED to choose what I actually want to do. So how do I translate that to a hole inspection pit that's this long, almost as long as the building? What I decided to do first of all was mount the LEDs on, and all the resistors, on some of this, which is strip board with the regular matrix of holes and copper strips. So my holes in the side of the Pico inspection pit had to be very accurately drilled. They had to be, I decided, on exactly a 1-inch pitch, which is 25.4 millimeters, which is 10 pitches on the Vero board, on the strip board, and they had to be very accurate, and I had to do that 6 times on both sides of 3 pits. So what I decided to do in order to drill those holes was, I seem to have lost something. Oh dear. Hang on, I will be back. Yeah, sorry about that. I've now found the pieces that I need. What I decided to do was do a drawing using my favourite Inkscape, which is here. I hope that you can see that. Yes, I think you can. So what that consists of is the sides of the inspection pit drawn with all the holes that I need marked out as a cross, and that will stick. The idea was that would, this is printed on peelable label, so that the idea is that they would stick onto the side of the pit in the right place, this being the datum end and this being the datum end of the inspection pit. That would sit on there. It's not quite long enough to go to the end, but the last hole is there, as you can see. And the plan was to stick it onto there and then very carefully with my trusty scriber, which is this, to mark the holes. And that actually worked out very well. I cut that out, stuck it down the side of the pit, and was very easily able to mark the holes, and then I drilled them out, ultimately in size to I think about 2.8 millimeters, which was a tight fit, an interference fit around the rectangular part of those LEDs. And then I just took the corners off the LEDs to let them in a little bit easier. So that worked okay. But how was I going to make the regular set of masks like this that also had to go all the way along here at 25.4 millimeter or 1 inch intervals? That was going to be a challenge. What I decided to do was that trying to do it on the inside of here was completely impossible. I was on a hiding to nothing trying to do that. So I accepted the fact that what I needed to do on the insides of the inspection pit was to add a piece of plastic card. Now this stuff that I used here to make this is 10 thou thick white plastic card, and I used the white plastic card here, this bit here, as the lens of the lamp. So what I decided to do was to do another drawing like this, which is now got all of the squares, the rectangles marked out along it, on exactly the same centres as the first drawing you saw, which is where I drill the holes. That gave me the opportunity to then take a piece of plastic card, like this, piece of 10 thou, stick one of those onto it. I have done left hand side and right hand sides of these, but to stick one of those onto there like that, and then cut it out, and then simply cut out around here all of these and peel off the excess. Unfortunately that didn't work, it was a failure. And the reason is that this peelable labels, when you get tiny little squares, which are I think 2 millimeters by 4 millimeters, I made them, they don't stay on, they fall off. There's just not enough adhesion. But at the same time it was no good using the non-peelable type of label, because I need to be able to get it off afterwards, because it was just going to be a mask for paint. So what I ultimately did was, onto my piece of 10 thou plastic card, I stuck a piece of Tamiya masking tape that was just a bit wider than what I needed. Onto the Tamiya masking tape backing, I stuck a strip of this, and that stuck very well to the Tamiya masking tape, and the Tamiya masking tape stuck very well to my 10 thou material. I then cut round these, well, I cut round the outline to get the right size piece of 10 thou plastic card, and then I cut round the outline of the squares, and then peeled off the majority of the masking tape and the label, just to leave my little squares hopefully positioned exactly 25.4 millimeters or 1 inch apart and at the right level. That all worked, apart from the fact that my printer and Inkscape together weren't very accurate. over the 200, there are 11 LEDs, which is 10 spaces, which is 10 inches, which is 254 millimeters. Over that 254 millimeter distance, when I printed from Inkscape to my inkjet printer, I was 0.8 of a millimeter out in 10 inches. So I had to stretch it a little bit in the Inkscape drawing by 0.8 of a millimeter, and then it was accurate. And from that point I managed to produce the parts that I needed to drill the holes, which I have here in this piece, all the way along both sides, and to produce the squared lenses for the lamps, again along both sides. The way I did this was, this is a piece of Pico inspection pit, and I sprayed it primer grey, a loose coat, a light coat, so that a little bit of Pico's original sort of what they consider concrete colour, which is not really very concrete, a little bit of it shows through, so that you get that sort of uneven grey. It'll be weathered as well eventually. The pieces of 10 thou are actually glued in on both sides, but before they were glued in they were sprayed first of all with my favourite primer, Acid 8, and then with black primer. It was actually not a primer, it was a satin black, because that's what I happened to have available, and on top of that the same grey that I sprayed the Pico inspection pit with. I then stuck all the parts together, and you can't see it, but I assure you that all the holes, the rectangles, all line up with the holes perfectly. So all I had to do then was try and fit the steps, which you can see on the end here. Now, because I've added 10 thou to each side of this trough, it's now 20 thou narrower, so the steps didn't go in. So what I had to do was actually again use my trusty diamond plate to take the sides off the steps so that they went in without squeezing the gauge open on the rails. I did put the rails in at the same time as I sprayed it, so they should be glued into place by paint, and I will just clean the tops off when I'm done. So we now have everything except one thing that I've got to mention, because if you look here, these rail fixings, these Pico rail fixings actually go through to holes on the other side, and that allows light to bleed through. Now my LEDs don't go quite into the side, so what I've done is I have put some 30 thou black plasticard into all the gaps along there, just so that through those openings where the rail fixings are, no light will bleed. And now I have a complete assembly. I've done one of these, and then we come to what are we going to do to fix the lights. Well, as I said to you, what I want to do is use this strip board. This is a piece that I've cut. I got this long piece of strip board, 90 millimeters wide and 430 millimeters long, I think. Got it from Rapid Electronics, and I've cut this to be long enough to cover all of the holes in the sides of the pit so that I can get the LEDs in. And then what I've done is I have cut a thin strip of it, which is just 3 strips of copper, and those 3 strips of copper will be the top one, as you look, will take the LEDs, the next one down will probably be 0 volts, and the bottom one will be 12 volts. The strip without any holes, it is just because strip board seems to come with that along the edge. The next strips won't have that on. And the LEDs go into here, and what I've done is I have cut, I've got an LED in there now. If you can see that, I really don't know if you can see that. There it is, it's focused now. What you can see is that I have made a cut, if I put that in the right place, between the two LED leads in the copper. And once again I used my trusty alpha cutter, this thing, to do the cutting with the hooked blade. And that's just cut the copper nicely for me. Also, that was the same tool that I used to cut this long piece off the edge of the strip board. That cutter nicely sits in between the copper, and if you draw it along, it takes the material out from between, and after about a dozen passes you're pretty much through. I haven't found a better way of cutting strip board over that great distance before. You can score and crack it, but it comes out a very messy surface. Anyway, what I intend to wire these up now is I intend to use those gaps that I've made. I will put 3 LEDs in. 2 of them will simply be joined together, so they'll go anode, cathode, anode, cathode, anode, cathode. That cathode will be joined to that anode. That cathode will be joined to that anode by a resistor, and the 3 LEDs plus the resistor will then be connected across to the 0 and the 12 volts at either end, and that will be one string of LEDs. There will be 22 LEDs in there, so that's 10 aside, sorry, 11 aside, can't count. So if I add one more LED, that'll make 12. That'll give me 4 strings of 3 LEDs with a resistor in that sets the current for 12 volt operation. The LEDs are about 3.3 volts each, which 3 of them is about 9.9, nearly 10 volts. I've got a couple of volts available for the resistor to set the current off of my 12 volts, and I intend to run them at around 2.5 milliamps. I can run one of these LEDs at 2.5 milliamps approximately to show you what that looks like. If I use my LED tester, there's one that I haven't taken the top off of, running at 2.5 milliamps. I have no idea whether that's focused. Come on, focus. There we go. That LED is running at 2.5 milliamps, which I think is plenty bright enough. When you consider how bright it is in this room, that is pretty good. So I'll run them at 2.5 milliamps in groups of 3. That means for each inspection pit there are 8 groups of 3 running at 2.5 milliamps. So that's 8 strings of current at 2.5 milliamps, which comes to 20 milliamps. So the whole thing is lit from 12 volts for 20 milliamps, which is pretty good going. What I would like to do is then use another one of my favourite little Merg kits, which is the Merg multi-purpose flasher, which has various things it can do, but one of its capabilities is to be able to mimic fluorescent lights being turned on, where you get that characteristic flicker, flicker, flick on. And I'm going to wire all of those up, and I can drive the whole of one pit from one of those, because the output of that is 25 milliamps at actually that's not true. I'm going to have to put a transistor on because I need 12 volts, not 5, so I'm going to have to put a couple of transistors on it to get it up, and I could actually therefore increase the current, but I think 20 milliamps is going to be quite bright enough, shining through that 10 thou plastic card. So that's as far as I've got. I haven't actually installed it yet, but I need to do this because I can't lay the track until I know where the inspection pits are going and have them ready to lay. So that's really one of the next things I must do. So I'm going to wind this video up now. So sorry that I haven't had more progress and only had one what appears to be very minor thing to show. I don't know when the next video will be available. It depends upon how my wife progresses. She's now about 2 weeks ago that she did it. She's got to go back to the trauma clinic. The fracture clinic have said she doesn't need to see them anymore. She needs to go to the trauma clinic, which will then give her another x-ray. That's in That's a week ago on Friday. Sorry, in a week's time on Friday this week. So we'll see how she's doing then. That will be nearly 4 weeks after she's done it. So I would say she's going to be on at least a 2 to 2.5, 3 months maybe healing process. So we'll just have to see how it goes. But modelling is going to be at a premium until then. So bear with me and I'll be back as soon as I possibly can. Thanks for watching. Bye.